If you're O positive, you're not just holding a blood type. You're holding proof. Proof that an ancestor of yours survived something that killed the people standing right next to them. And it's been sitting in your veins, unread, your whole life. You probably think your blood type only matters once, the day you need a donation. The rest of the time, it feels like a random detail on a form. You'd be wrong. Every blood type has its own quirks. And yours, type O, gives you real advantages the others don't. Let's get into what those are. Picture Vienna, 1901. A doctor named Karl Landsteiner is mixing blood samples on glass slides. Something is wrong. Some combinations stay calm. Others clot right away, like they're under attack. For years, blood transfusions had been a gamble. Some patients survived. Others died on the table. Nobody knew why. Landsteiner had just found the answer. He split blood into 3 groups, A, B, and O. A 4th group turned up soon after. Now, for the first time, a doctor could check a patient's blood before a transfusion and know if it would save them or kill them. The discovery won him the Nobel Prize in 1930. He'd solved the puzzle in front of him. He had no idea a second puzzle was hiding inside it, one that wouldn't be solved for almost 100 more years. Here's how it actually works. Every red blood cell you have gets built in 2 steps by 2 different genes. The first gene is called FUT1. Its only job is to lay down a basic marker on every blood cell you own. The second gene is the ABO gene. Its job is to decide whether anything gets added on top of that marker. In type A and type B blood, something gets added. In O-positive blood, that second gene is switched off. Nothing gets added. The marker stays exactly as it started. A third gene decides if you're positive or negative. 3 genes. None of them asked your permission. And together, they gave you the blood type about 3 billion people alive today also carry. For most of the last century, scientists were sure type A came first. It showed up on every continent, so it looked like the original. Then in 2012, geneticist Laure Segurel and her team at the University of Chicago read the gene in full detail. They proved that idea wrong. Type O, it turns out, appeared more than once in different places, through different mutations, in groups of people who'd never even met. Segurel's team then checked gorillas, orangutans, and macaques. They found the same A and B markers in species that split from us over 10 million years ago. In 2021, ancient DNA added one more piece. A Neanderthal carried a rare AB type, and a Denisovan carried O of her own. Your blood type didn't start with you. It didn't even start with humans. It's a trait we share with our primate ancestors, maybe one of the oldest still active in your body today. So why does type O dominate whole regions of the world? Look at the Americas. Among many indigenous populations there, almost everyone carries type O. The reason goes back to the end of the last ice age, somewhere between 15,000 and 20,000 years ago. A small number of families crossed Beringia, the strip of land that once connected Siberia to Alaska. They carried only the genes they happened to have with them. Think of it like dealing 5 cards from a full deck. That hand is the only one your descendants will ever get to play, no matter what else was sitting in the deck. Scientists call this a founder effect. It's not about the best genes winning. It's just about which genes happen to make the trip. Now here's what that inheritance actually does for you. And it's more than one thing. A Harvard-led study followed more than 100,000 people and found O carriers had the lowest pancreatic cancer risk of any blood type on the list. Type B ran 72% higher. Type AB ran 51% higher. Your heart gets a break too. O-positive blood naturally carries lower levels of a clotting protein called von Willebrand factor. A separate Harvard study of nearly 90,000 people found non-O blood types carried up to 23% higher odds of heart disease as a result. And it doesn't stop there. If you're O-positive, your risk of the worst form of malaria, the kind that can shut down your organs, drops in a way scientists can actually measure. Here's why. The parasite behind it needs your infected blood cells to stick together in tight rafts before it can do real damage. O-positive cells don't give it the surface it needs. The rafts never form. Blood keeps moving. 3 different threats, 3 different wins, all traced back to the same 2 words on your chart. But nothing in evolution is free. That same clotting protein cuts both ways. You'll likely bleed more than most after an injury or surgery. That's the cost of keeping your arteries clear. You're also more likely to get stomach ulcers linked to a common bacteria called Helicobacter pylori. It sticks to O-positive cells more easily than it sticks to A or B. And in 1991, cholera swept through Trujillo, Peru, a region descended from that same Beringia crossing. O-positive carriers there were nearly 8 times more likely to be hospitalized with severe disease. None of this makes your blood good or bad. It's a running tab, opened thousands of generations ago, and you're still paying it off today. And the tab is still open. In 2020, researchers studying COVID-19 found that O-positive patients were less likely to catch the virus in the first place, and usually had a milder case when they did. The same ancient code that carried your ancestors across Beringia was quietly at work in hospitals a few years ago. You were living through it without even knowing why. Then, in 1952, a doctor named Dr. Y.M. Bhende was working in a hospital in Bombay. He ran into something that shouldn't have been possible. A patient needed blood. Every test said, type O, the blood type doctors reach for first. Since it works for roughly 4 out of 5 people on the planet, they gave the patient type O blood. The patient's body attacked it instantly, like it was poison. That made no sense. O is supposed to work for almost any Rh-positive person. Bhende kept looking. What he found wasn't a rarer version of O. It was something underneath O completely. Standard blood tests only check for the A and B markers. They were never built to check for the marker underneath, the one those markers actually sit on. This patient had none of that base marker at all. No test on the books was built to catch it. They named it the Bombay phenotype. It's also called O, or the HH blood group, and it runs on a completely separate set of genes from the ones behind your A, B, or O. Anyone who has it can only get blood from someone else with that exact same rare condition. Nothing else works for them. It shows up in about 1 in 10,000 people in parts of India, and closer to 1 in a million people in Europe. It stayed hidden for decades simply because nobody built a test to look for it. And if that sounds rare, it's not even the rarest blood on Earth. Right now, around 43 people worldwide carry something called Rh null, nicknamed golden blood. They're missing every single Rh marker a body can have. That's about 1 in 6 million people. It works for almost anyone else who needs it in that system, but it's nearly impossible to replace if one of those 43 people ever needs blood themselves. The Bombay phenotype was already sitting inside you before this video. The malaria trade-off was already sitting inside you too. So was the founder effect that carried your ancestors across Beringia in the first place. None of this is new. Only our understanding of it is. O-positive was never just a label on your chart. It's what's left over from an ancestor who lived through something that should have killed them. It was passed down without ceremony until it reached you, and it's still on duty in your blood right now, still doing the job it was built for, whether you ever noticed it or not.